Hi there and welcome to tutorial number 2 under the topic work, energy and power. So in the previous tutorial we managed to solve 2 problems. In this tutorial we're also going to solve 2 problems, and then we can have a third, fourth and as many tutorials as we can under this topic. So we'll be solving many different problems. So let's move on and solve question number 1 from here. So question 1 in this tutorial is this one here. It says a 60.0 kg skier is at the top of a slope as shown in the figure below. At the initial point A, which is at the top, she is 10 meters vertically above point B. Okay, so just to emphasize the points here, point A is here and point B is here. Okay, so the first question A says, setting the zero level for gravitational potential energy at B, find the gravitational potential energy of this system when the skier is at A and then at B. So we're finding the the gravitational potential energy twice, at A and at B. And then finally find the change in the potential energy of the skier, Earth system, as the skier goes from point A to point B. Okay. Then part B says, repeat this problem with a zero level at point A. So if the zero level is now at point A up here. So we're going to find the potential energy at that point, and then find the potential energy at this point, and then also find the difference in potential energy as the skier moves from point A to point B. Part C, repeat again with a zero level 2.00 meters higher than point B. Okay. So how do we solve problems like this? So first of all, let's get the gravitational potential energy at point A and point B when we're taking point A as our zero level. That should be straightforward. Okay, so this is what we're doing here. So gravitational potential energy is of course the product of m, g and h, where m is the mass in kgs. Gravitational acceleration is of course acceleration in meters per square seconds, and height is of course a vertical length in meters. So clearly we've been given all these values here. So we simply just get m, substitute it there, 60. We get g, we substitute it here, that's 9.8. so we substituted this here, and then we also get h, and then we substitute that h right over here. So the product 60 times 9.8 times 10 gives us a gravitational potential energy at point A, which is equals to 5,880 joules. And then for part B, rather for point B, the gravitational potential energy again is the product of mass, gravitational acceleration, and the vertical height. But since that's the zero level, that means the height is 0. So we multiply 60 by 9.8 by 0. We simply just get the value equal to 0 joules, which is this here. So those are the two gravitational potential energies. At point A, we have 5,880 joules, and at point B, we have 0 joules. Now we have to get the change in the gravitational potential energy as the skier moves from point A to point B. So to do that, we simply have to get the difference in the gravitational potential energy between the 2 points, right? So of course the final point in this case is point B, because the skier is moving from point A to point B. So the gravitational potential energy at point B is the final gravitational potential energy, and the gravitational potential energy at point A is the initial gravitational potential energy. And so to get a change, we simply just get the difference in that. So change in gravitational potential energy is equals to potential energy at B minus potential energy at A. Now potential energy at B happens to be 0, and potential energy at A happens to be 5,880. So 0 minus 5,880 gives us negative 5,000. 5,880 joules. That negative there actually means that this gravitational potential energy is being lost by the skier. If it was positive, then we would have said it was being gained by the skier. Okay, so that's part A done. Then we can move on to part B. So part B, what was part B exactly saying? So part B was saying, we repeat this problem with a zero level at A. So if the zero level is at A, what is the gravitational potential energy at A, and what is the gravitational potential energy at B? All right. So the gravitational potential energy at A will be 0 because that's the zero level. That means the height from the reference point to where the object is 0. So that would be 0. So we're just reporting that here. We don't have to solve this over and over and over again. So we're saying when the zero level is at point A, the gravitational potential energy at point A is 0. But then at point B now, that means that height, 10 meters, is now below the reference point. So because it's below the reference point, that's going to be a negative value, isn't it? All right, so now at point B, we have mg multiplied by hb, which is the height at point B. We multiply that, we have 60 times 9.8 times negative 10. Negative 10 because, remember, it's below the reference point. So that gives us a negative 5,880 joules. To get the change in the gravitational potential energy, again, remember, point B is the final position because the skier is moving from A to B. So again here, to get the difference, we're going to say change in potential energy is gravitational potential energy at point B minus gravitational potential energy at point A. And that's exactly what we're going to do here. So you can see that's what we have here. So the change in gravitational potential energy is equals to PEB minus PEA. So the gravitational potential energy at point B was negative 5,880 minus 0. That's going to leave us with negative 5,880 joules. So that's part B solved. What does part C say? Part C says repeat again, but this time with a zero level at 2.00 meters higher than point B. Okay, so what we're looking at here is our zero level is actually going to be somewhere here. Okay, where the length from there to down here is 2, and then from here to there it's going to be 8 because 10 minus 2 is 8, right? Okay, so let's see, how do we solve such a problem? We have that here. So all we need to do is to find the gravitational potential energy at point A, which in this case is going to be at a height of 8 because the zero level is at 2 meters. So when the zero level is at 2 meters higher than point B, the gravitational potential energy at point A is given by the product of mg and the height at that particular point. So that's 60, which is the mass, multiplied by 9.8, which is the gravitational acceleration, and then multiplied by 8, which happens to be the height, with reference point being at 2 meters higher than B. We multiply those values, we get ourselves a value equals to 4,704 joules. Then at point B, now point B is going to be 2 meters lower than the zero level, right? So to find the gravitational potential energy there, we'll simply just multiply the mass, the gravitational acceleration, and then the height, which in this case is -2 because it is -2 below the zero level. So that gives us a gravitational potential energy equals to -1,176 joules. All right, now to get, remember, this is the gravitational potential energy at point B. This is the gravitational potential energy at point A. So if we want to get the change, which is what the question says, we have to subtract. Now remember, point B is our final position, and point A is our initial position. So to get the change, we'll simply just say the gravitational potential energy at point B minus the gravitational potential energy at point A must give us the change. And so you see we are saying negative 1,176 minus 4,704 gives us a negative 5,880 joules. We have solved question 1C as well. So if you look carefully, notice the change in the gravitational potential energy is the same for all parts, part A, part B, and part C. Okay, so let's move on to the next question, which is question number 2. So question number 2 says, a cable exerts a constant upward tension of magnitude 1.25 times 10 to the power 4 newtons on a 1.00 times 10 to the power 3 kg elevator as it rises through a vertical distance of 2.00 meters. Find the work done by the tension force on the elevator. B. Find the work done by the force of gravity on the elevator. Okay, so to find the work done by the tension force on the elevator, we need a force being applied and then also a distance covered in the direction of that force. Okay, so this should be straightforward. But before we can talk about how to solve that particular problem in the steps which I've outlined here, let's just look at the data which we have here. So the tension force has been named as Ft, and that's equal to 1.25 exponential 4 newtons. The mass is 1.00 exponential 3 kgs. The gravitational acceleration is always 9.8 meters per square seconds. And the height which it has moved to is equals to 2.00 meters. So let's get the work done by the tension force then. So the work done by the tension force will be calculated using this equation here. Work is equals to F cos theta multiplied by the displacement vector in the direction of the force. So in this particular case, because the force and the displacement are in the same direction, the angle between them is actually 0, right? So simply put here, we're going to have F cos 0 multiplied by the height, which is the displacement vector 2.00. And so cos 0 is 1. We multiply that by 1.25 times 10 to the power 4. That gives us the same value. We multiply that by 2. We get the work done by the tension force equals to 25,000 joules. And that's the work done by the tension force. Then the other question, question B, says find the work done by the force of gravity on the elevator. Okay, so the pull of gravity on this particular elevator is equivalent to its weight, isn't it? All right, so we are going to use the same equation, which is this one here. Let me just highlight it alone. So we're using the same equation, which is this one here. But in this case, the value of F there is the weight, because that's the pull of gravity on the elevator, isn't it? And so notice that H becomes mg in the next step here. So this is what we're talking about here. So work done by the force of gravity G is equals to mg cos theta multiplied by H. Okay, so mg can be gotten by multiplying the, of course, mass and gravitational acceleration. So that's 1.00 times 10 to the power 3 multiplied by 9.8 cos. Now notice the angle we're using there is 180 degrees. The reason is because the force of gravity acts downwards, but the distance being covered, or the displacement vector being covered, is in the other direction, which is upwards. So when you get two forces, when you get two quantities where the displacement is in this direction and the force is in that direction, you will notice that the angle between them here is going to be what? 180, straight line, right? Okay. So when you do that, of course, we multiply through all that by 2, we get a value equals to 19,600 joules. And that happens to be the amount of work done by the force of gravity on the elevator whose mass we have been given there. And this brings us to the end of our second tutorial under work, energy, and power. I'll see you in the next one.